Okay, this is the second part of Chapter 6 we're going to look at today. Let's go back, and you'll recall that hang on, I need to erase some things from earlier that I was doing. When we looked at these problems last time, the last example, go one back. The last example was looking at what percent of scores would be greater than 85. And we said, we didn't really know exactly. We knew it was bigger than 16%, but that's about as accurate as we could get, right? A little bigger than 16%. Well, why was that again? Well, if we go back and draw our picture, we said, okay, these tests had a mean of 82, a standard deviation of 4. All right, so we can go 4 above, and we can see one standard deviation out is would be at 86. But we're looking at what percent would be greater than 85, right there. So we know we could figure out that these two were one standard deviation away. We know that 16% left up in this upper tail, but we've got a little bit more than that. Well, how much more? Well, we can find that out exactly using tables that statisticians have developed or using technology. So these are the steps we're going to follow. You're going to draw a picture, which we've already done for this first problem here. All right, you draw that normal model, you shade the percent you're trying to find. Make sure you label the mean and that you show your standard deviation either by just stating it here or by showing it by marking out standard deviations on your graph. Okay? Compute the z-score. All right, so for this problem, there was our picture. Let's do the z-score. Our test score was 85 minus the mean of 82 divided by the standard deviation of 4. That gives us 3/4 or 0.75. So that score of 85 is not quite a full standard deviation above the mean. It's exactly 3/4 of a standard deviation above the mean. All right, so how can we figure that percent? Well, go to your table, and there is a table in your appendix in the back of your book, and I think I marked that on your sheet. It's on A74, A75. So if you want to go to those pages, you can, or you can look up here. What we do is we look up this z-score in the table by starting with the tens place, right here, 0.7, and then the column is the hundredths place. So there's our 0.05. So if we look where that row and this column intersect, they're going to intersect right here. Okay? What does that mean? Go back and look at this picture. This shaded area, these charts always give the percent below the z-score you're using. So we're using a z of 0.75, so we're saying that's 0.75 standard deviations away. So this shaded area is 77.34, or let's just say 77% of the area under that normal curve. Okay, so let's take that back to our problem. So now we know that this over here is 77%. All right, but is that what we wanted? No, we wanted the part above that z-score. Well, that's easy because we know there's 100% of the data underneath the curve. So to find the actual value, we can just take 100 minus the 77 and get approximately 23%. All right, so about 23% of the scores are going to be greater than 85. Okay, so that's all we're doing. That's the only thing really that's different from those examples we did last time. Instead of our z-score being a whole number, it's going to be a decimal of some sort. And we have to use either the tables or the calculator to figure that out. Now, it's hard. I can't bring up the calculator on the recording for some reason. I guess because it's not a smart notebook thing. So if you look at the back page of your packet, it'll tell you how to get the value on your calculator, but that's something we'll also go over in class. So just kind of hold off on that, or if you want to try to figure it out on your own, you can. There's also a section in your book in Chapter 6 that has the technology tips that tells you how to do it on your calculator as well. Okay? So for right now, though, let's use the table again on this next problem. Suppose a normal model describes the fuel efficiency of cars currently registered in Missouri. The mean is 24 miles per gallon, and the standard deviation is 6 miles per gallon. What percent of all cars get less than 15 miles per gallon? Okay? Well, let's start with our picture. I'm going to go ahead and draw it over here so we have more room. Okay? We've got a mean of 24. We've got a standard deviation of 6. I'm looking. I don't like to mark up and draw all 3 standard deviations. You can if you want, but I think it just makes the picture cluttered. I just mark what I have to. I want to look at getting less than 15 miles per gallon. So 15 is to the left of 24. Each standard deviation is 6, so I'm just going to mark these on the left. So 24 minus 6, that's 18. 18 minus 6 is 12. That's really all I need to know, because now I can see my 15 is somewhere in between the 12 and 18. So that's the gas mileage I'm looking at. And I'm looking at what percent get less than that. So this is the area, or the percentage, I'm trying to find. Okay? So there's the picture. Shows what we're finding visually. Okay? The z-score. All right, z equals the value we're at minus the mean divided by the standard deviation. You do that, 15 minus 24 is negative 9. Remember, a z-score is negative when it's to the left of the mean. And that reduces to negative 3/2 or negative 1.5 if you want it in decimal form. So this value of 15 is negative 1.5 standard deviations below the mean. Okay? So we're going to go to our table. Now, this table that we looked at, notice all the z's were positive. The other table that you'll have, either in your book or the sheet I give you, will have z-scores that are negative. And so we want negative 1.5. All right? So keep looking down the chart here, and you should see negative 1.5 right there. And it was just negative 1.50, right? So notice up here, these are the .00s. This chart kind of reads backwards, right to left. So where that column and this row intersect is right there at 0.0668. All right? And again, these tables always give us the percentage below the z-score we're using. So that's exactly what we want this time. So our table tells us that percentage is, we said 0.0668, right? Which in percent form would be 6.68%, or approximately 7%. Remember, AP Stat is not too picky on how you count. Okay? So about 7% of cars currently registered in Missouri, if they're normally distributed, get less than 15 miles per gallon. Okay? All right. I would like you to maybe think about how we could go about answering the next question. What percent of cars get between 20 and 30 miles per gallon? Think about that for a little bit. I think this is a good place to break the video, and then you can click on the next video to see if you were right.